Hello, welcome to the nonlinear analysis video for the Lilly version of the Powerstaxx tolerance analysis program. In this video, we will review how to use the nonlinear analysis capabilities of Powerstaxx. For this video, we will assume that all the necessary dimensions have been added to the dimensions sheet. With that complete, we will start here on the tolerance analysis sheet. By default, each stack-up is set to perform a linear tolerance analysis. That is indicated by this cell that reads standard formulas. Therefore, the first step in creating a nonlinear analysis is to click this button to the right of the tolerance stack-up that says Use Nonlinear Formulas. Several changes occur when that is done. The button just pressed changes to Calculate Nonlinear Equations, and a new button, Use Standard Formulas, is added. Pressing that new button reverses the changes just made back to the default condition. Since we want to perform a nonlinear analysis, we will click this button again. Other changes occur in the middle of the results section. The standard formulas flag changes to nonlinear formula, which points you to the cell where the user-created nonlinear formula is entered. This cell here tells the user to enter the perturbation amount to be used for the calculation. The default value of 001 is entered, but that value can be changed at the user's discretion. The final changes occur in the column titles where min and max change to sensitivity and applied tolerance. The sensitivity indicates how much the resultant or sum value of the stack-up changes as that dimension varies. If it is a large number, that means the result of the stack-up will change a lot for a small change in the dimension, and that would be considered a sensitive dimension. Sensitivity can be positive or negative. The applied tolerance is the nominal tolerance of the dimension times the absolute value of the sensitivity. The applied tolerance is used on the root sum squares calculation to determine the variability. If we click on Show Images, we will see a drawing of the nonlinear stack-up we want to study. The assembly is of a wedge between two parts, and we want to know the gap between the wedge and the base of the assembly. The dimensions are already added on the Dimensions tab, so we will enter them in the Dimension ID column. For a nonlinear analysis, the direction impact column has no use, so Powerstaxx automatically makes it read formula. Let's type into the comment cell the formula already derived for the gap we are interested in, using the dimension ID values. The formula is gap equals B2 minus the sum of A1 minus B1 minus W1 divided by the tangent of W2. Now let's enter that formula using Excel syntax into this cell here, remembering the angle is given in radians. With that complete, notice that the variability remains 0, and so does the sensitivity and applied tolerance columns. That is normal because we need to execute a macro to calculate the result. To execute the macro, click on this button here. After a few seconds, it is done, and we have our results. You can see the sensitivity ranges from negative 2.74 to positive 2.74. Given that there is a relatively shallow angle on the wedge, this is expected. See that the applied tolerance for the dimensions with the greatest sensitivities is nearly 3 times the nominal tolerance. Also, there are no negative signs in the applied tolerance column because they are squared in calculating the variability, and negative tolerance doesn't make practical sense. While not every change to a nominal dimension value requires executing the macro again, it is recommended that be the standard practice. Therefore, if a nominal dimension changes, a flag appears advising to rerun the macro. Let's go to the dimension sheet and change one dimension. Back to the tolerance analysis sheet, we see the run macro flag is visible. Of course, if the formula is changed, it must also be rerun, and the flag also appears. To complete the stack-up, enter what is being evaluated and what is required. We will enter what is the gap between the wedge and the base of the channel here, and clearance here. If the objective is just clearance, then the low limit is 0 and there is no upper limit. That concludes the nonlinear analysis video of Lilly's custom version of the Powerstaxx tolerance analysis spreadsheet. Please watch the other videos to learn more. Thank you for your time.